We are doing analytical geometry. We are proceeding with the questions that you sent to us. Remember, we're trying to help you to understand how do you answer them. But like I said, my interest goes beyond analytical geometry. I want you to have an open mind when you're dealing with these things. This is how far analytical can take me, but sometimes I might need other topics to carry me as I move forward. Right, please keep that in mind. Okay, cool. So the next question comes from Kendi Makanya. Kendi, thank you very much for sending us this beautiful question, and I like the way you phrased your question. But it says, you said, please help me with number 2. I don't understand the question. Okay, that's very descriptive. It explains to us that you're stuck, you don't know what is going on with the question, you don't know what the examiner is asking you. And remember, if that is the problem, then you will never be able to solve whatever they're asking you to solve. If you don't understand the problem, then it's actually very serious, right? Okay, and the next one I'm going to do is going to be from DK Little. DK, if you're also watching, stay tuned. The next question is going to be yours because Makanya's question is very short. It's not complicated. It's very short, and it speaks to us about what is a tangent, right? Very important for you to keep that in mind, right? Okay, let's look at what is going on. I tried to write it down. Please help me with number 2. I don't understand the question. This is what Kendi said to us. All right, and then the actual question says the following. It says, find the equations, right? Find the equations of the tangents. Find the equations of the tangent. So apparently there's a lot of tangents here. Okay, cool. To a circle. Where is the circle? Well, the circle is x minus 2 squared plus y plus 3 squared equals 16. Right, which are, okay, this is where it becomes interesting. All right, and I want you to imagine this as I'm going to be writing it down. Imagine what is going on here, okay? We have to find the equations of tangents to x minus 2 squared plus y plus 3 squared equals to 16, which are Roman figure 1, parallel. Okay, this is interesting. To the y-axis. Okay, no problem. The second one is the ones that are parallel to the x-axis. Okay, Kendi, beautiful stuff. Right, now, let's start first of all and analyze the story behind parallel to y-axis and the meaning of parallel to the x-axis. I think you guys know the Cartesian plane. It's not a Cartesian plane. It's Cartesian plane, right? Let's think about a Cartesian plane. So a Cartesian plane looks something like that, right? If I need to draw, in context of Roman figure 1, a line that is parallel, keyword parallel, to the y-axis, what kind of a line would that look like? Well, it's going to be either this one, or this one, or this one, or this one. So I can draw any line that is parallel to the y-axis, either on the positive part of the x-axis or on a negative part of the x-axis. All those lines are simply parallel to the y-axis. The second question is asking for those that are parallel to the x-axis. What would those ones look? But before I even get there, it means the lines that are parallel to the y-axis are all what we call vertical lines. Those are going to be vertical lines, right? Okay, cool, right. And then there's ones that are going to be parallel to the x-axis. What do those ones look like? Well, the ones that are parallel to the x-axis are simply going to be horizontal lines. How will they look? Well, they look something like this. They will all look like this, or like that, or like this, or like that. This is the ones that are parallel to the x-axis. I think that part was clear, Kendi, because I'm worried by the fact that you say you don't understand the question. So I don't know where the problem could have been, so I'm trying to go as deep as I can to make sure that you're not lost. So the ones that are parallel to the y-axis are vertical lines, but the ones that are parallel to the x-axis are horizontal lines. Okay, right. They are horizontal lines, all of them. Now, according to this question, right? According to this question, if I need to write down the equation of any line that is parallel to the y-axis, we're going back to vertical lines. Let's go back to the vertical lines. Beautiful people who are currently watching Tenfold Live, any vertical line will always have the equation x equals to something, right? They will all have the equation x equals to something, some constant, some number that you're going to have there. If this first line was passing at 1, its equation was going to be x equals to 1, if this was passing at 1. If it was passing maybe at 7, here, when x is 7, its equation was going to be x equals to 7. If the far left line, far left white line, was passing here at, of course it's negative, so maybe let's just say it was negative 1 over 2. Its equation is going to be x equals to negative 1 over 2. Any line that is a vertical line, we'll always have the equation x equals something. Keep that in mind. Now for the horizontal lines, those ones, what about them? Well, all horizontal lines will have the equation y equals something. For example, the top line, let's just make an assumption and claim that it was passing at a point where y, let's just assume that y here was 3. The equation of that line was going to be y equals to 3. Let's assume that this one was passing when y is 1. Its equation is going to be y equals to 1. The bottom line, the smallest one, the far bottom line, let's just say this one was passing at minus 3 over 7. Its equation is going to be y equals to minus 3 over 7. So very important for you to keep that story in mind, right? Okay, let's start with the ones that are parallel to the y-axis. But we can't deal with them if we don't, of course, see the circle, because they have to be tangents to the circle. We're not going to have many lines. We're going to have 2 lines only, I'm thinking, that are vertical, and 2 lines that are horizontal, because they're going to be on either side of the circle, right? Because they happen to be tangents to the circle that we're given. So let's try to draw that circle that the examiner is talking about. Again, it's not easy for you to find a solution without something that you can visualize. So a visual aid, these diagrams are going to actually help you, because if you draw them, they make things a whole lot easier for you. Okay, cool. So where's my circle? Well, here's my circle. I'm going to draw this circle and try to draw it as nice as I can. Okay, we see that circle. Let's just move it a bit lower. Okay, cool. We're happy with that. All right, now what's the story? The coordinate of the center, right? The center of the circle. If that is x minus 2, I know the x coordinate is going to be plus 2. If that is y plus 3, I know the y coordinate is going to be minus 3. They're always opposite signs to what you're looking at. And the radius is obviously going to be the square root of 16, which means it's going to be 4. So this is a point that lies on which quadrant? Yes, somebody has guessed it. This is going to be on the 4th quadrant, which means the Cartesian plane is going to pass something like this, something like that, right? This is how the circle would look in an exam context, right? They would even draw it for you, I'm thinking, to make things easier for you, because we don't want you to draw things that will waste your time. Okay, cool. So I'm looking at that and I'm happy about what I see here. What do I know? I know the center is 2 and negative 2. I already have that. The other thing I know is that the radius of the circle is equal to 4 units. That's what is important. Keep that in mind. Now, I want to start by answering Roman figure 1. I want to draw a straight line that is going to be parallel to the y-axis. I'm going to draw it, right? I'm going to draw it. Let me change color, right? Here's a straight line that is parallel to the y-axis. But that line is not a tangent to the circle. I want it to be a tangent to the circle. So what am I going to do? I'm going to move it. So let's move it. We're going to move it so that it's a tangent. So we're moving it until it becomes a tangent to the circle, right? This is me trying to be fancy by using technology wisely, right? So there it is. Now it is a tangent. But this is not going to be the only line parallel to the y-axis that is happening to be tangential to the circle. We can have the other one, where on the far left of the circle. So let's have that one as well, right? Let's have that one as well. Okay, cool. Let's have that one as well. There's my other line parallel to the y-axis, but it's not a tangent at the moment. We want it to be a tangent, so let's move it. Let's move it. We're going to move it until it becomes a tangent to the circle. It's not. Let's make sure it's a tangent. It's a tangent. Okay, come now. Don't mess me up. Beautiful stuff. Right. There we have it. We've got 2 tangents that are happening to be parallel to the y-axis. Those lines are parallel to each other. They're also parallel to the y-axis. This is parallel to that. It's also parallel to the other line. Right. So we're looking for the equations of those 2 lines. Now this is easy. Why? Because you just look at the x value here. Look at the x value there. The x value at the center is 2. That's 2. And now I'm moving to the right. I'm moving to the right. How many units am I moving to the right? I'm moving radius units to the right. I'm going to move 4 units, because from the center to where the tangent meets the circle, that's just the radius. So I'm just moving 4 units to the right, which means I'm adding 4 as you move to the right. Where will I end up? I'm going to end up at 6. So this is going to be where x is equal to 6. So the equation of this line is going to be x is equal to 6. The same story when I go left. Same story applies when I go left. I'm at 2. The center at 2. Where am I going? I'm going left. I'm going left. Where is left? Left is left. Where? This side, right? So I'm going that way. But how many units am I moving? I'm moving 4 units left. But remember, this is a Cartesian plane, so pay attention to what happens to the signs of the numbers. So when I move 4 units left, I'm going to move from 2 to minus 1, to 1, to 0, minus 1, and minus 2. If I move 4 units left, I'm simply going to end up at negative 2. So which means the equation of the second one is just going to be as good as x is equal to -2. So those are the equations of the lines that are parallel to the y-axis that happen to be tangents to the circle. I need two more. Which ones are those? I need those that are parallel to the x-axis. Okay, the ones that are parallel to the x-axis, the first one I'm going to draw it in green. Let me just draw it like that. This is the line that I'm going to be looking at, that one there. It's touching the circle at that point there. It's going to pass at the point where y is something. So its equation is going to be y equals to some number. Now, what am I interested in? I'm just going to try and check how high. If I move from the y-coordinate, if I move from the y-coordinate once more, y-coordinate at the center, and I'm going to the tangent, and I'm moving other units, the radius, you just add 4. The radius is 4 in any direction, whether you're going right, or you're going left, or you're going up, or you're going down. Locate the center, move 4 units up, because the radius is 4. So the center has a value of -3 as its y-coordinate. So on -3, we're adding 4. We're moving 4 steps up. We're definitely going to end up at 1, right? So which means I'm going up 4 units. I'm going up 4 units. When I go up 4 units, I'm going to end up at 1 because it's from -3. You're going up, you'll end up at 4. So the equation is going to be not y equals to 4 Schofield. Fix that is going to be y is equal to 1, right? The other one is going to be at the bottom. There's the other tangent is going to be here. Of course, it's going to be a tangent. Excuse that. It's also going to be y equals to something because it's cutting y at some point. This is the one that is parallel to the x-axis, right? So that line, also, I'm just asking myself, how many moves am I making from -3 going down? I'm making 4 moves. When I make 4 moves from -3, I'm going to end up at -7. So that's going to be the equation of number 2. So in order to answer your question for Roman figure 1, the answers are x equals to -2 and x equals to 6. Those lines are parallel to the y-axis. For Roman figure 2, y equals to -7, and the other one is y equals to 1. Beautiful question indeed. That is out of the box.